Yeah, good afternoon, everyone. And
Good afternoon, sir.
today and tomorrow, we have two sessions, and tomorrow will be last lecture of this module. So essentially, we covered basics of number theory and a little bit of algebra in this session in this module. So I plan to take mixed problems for today and tomorrow. So what topics we did in all, not only me, various teachers. So initially, I started with some puzzles
Yes, sir.
just as a warm up, and then we did divisibility, then division algorithm. We talk about primes and properties of primes. Okay, so we did primes, and what else? We did GCD LCM, right?
Congruence.
Yeah, congruence we did last. That was the last thing we did. Then yeah, I think these were the topics, right?
Magic, sir. Arithmetic.
What?
Magic, sir.
Arithmetic. I don't understand properly.
Magic, sir.
Crypt arithmetic.
Oh, crypt arithmetic, yeah.
Crypt arithmetic, yeah.
Okay, yeah. So crypt arithmetic.
Magic, sir. Congruence.
Congruence in number theory, not from geometry. So something like this, right? So I plan to take mixed problems based on all these topics so that it will be a good revision of what we have learned in this module. Shall we start?
Yes, sir.
Okay, so here is first problem. Observe the following pattern. Observe the following pattern. In fact, many times in maths, you look at patterns. It's about patterns, and you decide some theory based on that. Observe the following pattern. One. Should I use a different color here? 1, 2, 3, 4, 5, 6, 7, 8, 9. You write neatly in your notebook with proper alignment. Then 10, 11, 12, 13, 14, 15, 16, and so on. So I just put dot, dot, dot. So which means and so on. Okay. So question, as usual, don't disclose the answers. You can either raise the hand to tell the answer, or you can write down in chat box, but only to me, not for everyone. Be careful about that. Then in which row and at what position from left. Number 2023 will occur. Okay, so I will explain the question if you want. Look here carefully. This is first row, and first row contains only one number, namely 1. This is second row, and second row contains 3 numbers, 2, 3, 4. Third row contains 5 numbers, 5, 6, 7, 8, 9, and so on. Okay. Next one, fourth contains 7 numbers, and so on. So if we go on writing like this, the number of terms will increase from each row, and in which row there will be number 2023 and at what position? That's the question. Is the question clear to everyone?
Sir.
Your answer is correct, but
Sir,
yes,
I sent my answer in the chat. Am I correct?
yes, Shion, who is that? Saket. That's
Yes,
right.
Saket.
The Yashraj also.
Yeah.
Sir, Saket?
Yes, Saket. Yeah, right. Shion, you have to write at what position it will be in that row from left side. That's why you have to write it from left side. What number it is? Saket, you have to write in which row, which row number.
Oh, yes.
Yeah.
1 minute.
So
Just
your
check.
position is correct. Position is correct.
So the position is the last one you can calculate. The row I calculated before only. I sent
Yeah.
in the chat.
Yeah.
Am I correct? Sir, am I correct?
Yes, yes. I'll give you some time to think some of your written answers. But as usual, I want more answers from most of you. So this is a problem which is kind of puzzle as well as it contains some algebra. So observe carefully the pattern and based on that, think about where 2023 will occur, in which row, and at what position. So for example, what are numbers you see? For example, I'll say 15 occurs in fourth row, right? And at what position from left? 1, 2, 3, 4, 5, 6. And sixth position from left, right?
Sir, I sent my answer.
Okay. Shion, Dashraj, correct. Both are correct. Okay. Second, you can take your hand down.
Sir, I sent my answer. Is correct.
Who is that?
Yes.
Yeah.
I just I went to the washroom, sir. Is there a new question?
No.
And then why are people I sent my answer?
It's for the first question.
Sir, is my answer there?
Yeah, row number is correct. That position I think is little bit misplaced.
Okay.
Yeah. Shall we start discussion?
Good evening, sir.
Who is that?
Sir, could you just 2 minutes?
Okay.
Good evening, sir.
Yeah, who is that?
Sir, I agree.
Okay. Yeah.
Sir, I joined a little late. Can you tell me what
Yes.
are you
So today we'll be doing mixed problems. sorted problems. This is first page. And based on what all we have learned in this module, I'll be giving mixed problems. So this is first problem.
Sir, is tomorrow the last module?
Yes, yes. Tomorrow will be last lecture of last session of this module, and next week we'll be starting with new module. So in this module we mainly covered number theory, and in next module we'll be covering algebra and combinatorics, and in last one we'll be covering geometry.
Sir, Raj Haparwala said my answer. Can you check?
Put my answer right. I have sent the.
Somebody's audio is on. Yeah, Vijay, now it's correct. Okay, so now look here. In first row there is only one element. So I'll dots for number of elements. And then in second row there are three elements. I'll write it this way: 1, 2. Somebody's audio is off. Okay, so in second row there are three elements. I denote this way: 1, 2, 3. Then in third row there are five elements. I'll put it this way: 1, 2, 3, 4, 5. And you see basically all these numbers are square numbers, right? So you see every row ends with a square. 1, which is 1 square, 2, which is 2 square, 4, which is 2 square, 9, which is 3 square, 16, which is 4 square.
Sir,
Yes.
because 2023 is a big number, there is a shortcut to finding what's the closest square. So can I say?
Yeah, yes.
Sir, can I tell my method?
Just a minute, just a minute. Let me complete and then all of you can tell your solutions, okay? So we have squares ending at each row, right? So every row ends with a square. Every row ends with a square. First row will end with 1 square. That is 1. Second row ends with 2 square, which is 4. Third row ends with 3 square, which is 9, and so on. Okay. Now I have to find some square which is just next to 2023. So to find square, find the first square or
So can I?
the nearest square to 2023. Saket, what is that?
Okay, sir. So when I was thinking of numbers next to 2023, I just thought like that about that rule of um of finding squares ending with 5. Okay,
Yes,
so
very good.
I realized that like when I was just thought of 2023, I thought of 2025 ending with 25, and there is a rule such that like if there is like if you want to find the square of a number which ends in 5, you have to keep put 25 in the end, and before 25 you have to have a product of that number and the next number. So it's very confusing, but I'll just tell you that to 2025 you can break it as 25, and before 25 is 4 into 5, so therefore it's 45 squared.
Okay. Yeah, just a minute, Saket.
I did it like this. 2023, I saw it is between 40 square and 50 square. So I tried with 45 square, and that is
Yeah,
2025.
that's good, yeah. So you take
Sir,
some.
mine was the same method as Saket's method, sir.
Yeah, so you take some estimate. Like for example, this was good. Who said that 2023 lies between 40 square and 50 square, and then you go further. Like
Actually, it's 2023.
Oh, sorry, 2023. Yes, sorry. 2023. So what should I do? I should erase that. Right? Yeah, so 2023 is between 40 square and 50 square. And then you reduce the boundaries. Like you increase this boundary to the right side and you reduce this boundary to the left side. Okay, so you make your bounds more and more finer. So for example, you see that 44 square is smaller than 2023 and 45 square is larger than 2020. Okay, so let me tell Saket's method about, so it's so from so-called Vedic mathematics. So how do you square numbers ending with 5? So I want 45 square, and what I have to do is take square of 5, that is 25, and then 4 into the next number. Right, Saket? 4 into the next number. So that is 4 5 are 20, and that's how you can find square of any number. In fact, Saket, more generally, what you can do is if you have numbers with same tens place digit and the unit place digit which are 10 complements of each other. So like suppose I want 44 into 46. I do the same thing. So 6 fours are 24. 6 fours are 24 and 4 into next number. 4 into next number. Okay. Or 43 into 47. Or I mean not 43, 47, any in general, any number. So let's take some details. So 53 into 57. So 3 sevens are 21 and 5 into next number. 5 into next number is 6. So 5 6 are 30. So answer is 30, 21. So it's not only for squares ending with 5. It's more generally. So like for example, when I say 45 square, it's 45 into 45. So you see the two last digits are 10 complements. 5 plus 5 is 10. Right? And the same method works. Is this clear to everyone?
Sir, does this shortcut method work in each and every like if you want to find any square, so will it work in each and every square?
Yes, so tell me what is 44 square? So let's see your shortcut. How do we find 44 square?
So it's sockets.
No, somebody said shortcut for every
No,
square.
sir, I said that does this shortcut which Sakit said, does it work for each and every number?
No. It's only for numbers ending with 5, or more generally, as I said, it's for products where the unit place digit are 4 complements and tens place digit is safe. So like for example, 73 into 77. So 7 plus 3 is 10 and this digit are safe. So more generally for all such products, it works. So for example, this will be 7 3s are 21 and 7 8s are 56. So this is 5621. And then in particular, you see if I want 45 square, the end digits are tens complement. 5 plus 5 is 10 and tens place digit is same, 4 and 4. So it works. Okay.
Sir, does it work for 3-digit numbers?
Yes. So for example, if I have something like 105 into 105, so it's 25, and 10 into 11. 10 into 11 is 110. So it's 11025.
And sir, why does it work?
Yeah, so we can prove that using algebra. But right now that's not the point. So maybe in our next module in algebra, we'll do.
Sir,
Okay.
sir, I have a doubt.
Yes.
Sir, how do you find that the 2023 is the square between 40 square and 50 square?
Yeah. So 44 square is 4 square is I know 4 square is 16. Right. So 40 square will be 1600 and 5 square is 25 So 50 square is 2500. So surely my number lies between these two. So I surely know that it's between 40 and 50 squares, right?
Yes.
And then step by step you go on increasing your limit. So for example, here you check 41, here you check 49, here you check 42, here you check 48, and so on. So ultimately you'll find that 44 square is smaller, 45 square is large. So it's consecutive squares. Okay.
Yes, sir.
Sir, there is some noise coming.
Yeah. Noted. Okay. So let me go ahead. Still we haven't completed the problem. So yeah, so 2023 lies between 44 square, 45 square, right? And therefore, it's surely not in 44th row, but it will be next to 44th row. So 2023 lies in 45th row, right? Lies in 45th row. Okay?
Yes.
Yeah. And 45 square, as Saket said, is 2025. So, so let me again show something related to pattern. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and so on. So see that in 45th row, I'll have 2025. One before that is 2024. One before that is 2023, right? But I want to know position from left side. Okay, so like for example, 14 is second last in that row, but I want 14 is at what position from left? And you see in this case, 14 is 1, 2, 3, 4, 5. So at fifth position from left. So I want same thing about 2023. Okay. So observe the difference.
So we basically find the number
Can I
of
tell?
the number of numbers in that
Yeah.
row.
So I want the total number of integers in each row. Then I can get what is position of 2023 from left side. Okay.
Sir, can I say?
Just a minute. Just a minute. So observe that in second row, I get two more elements. So it's 1 plus 2, 3, right? There are three elements. In third row, I get earlier row plus 3. So there are 5 elements, right? In fourth row, earlier number plus the current row, 3 plus 4, 7 elements, right? So similarly, in 45th row, there will be 44 plus 45. There will be 89 elements. 89 elements.
Sir, can I tell another way?
Right? So total number of elements in 45th row is 89. All of you agree with that?
Sir, can I tell another
Yes.
way?
So why would you say that it's 44 plus 45? So can you repeat?
So look at the pattern again. So just from pattern. So what is the difference between 4 and 1? That is sum of those two numbers. 1. So this is first row. This is second. Just a minute. I'll use some different color. Yeah, this is first row. This is second row. This is third row. This is fourth row. And observe that in second row, how many elements are there? 2 plus 1. Okay. Then in third row, how many elements are there? 3 plus 2. Okay. Then in fourth row, how many elements are there? 4 plus 3. So current row number plus the earlier row number. So in 45th row, how many elements will be there? 45 plus earlier number, 44. There will be 89 elements. Now out of 89, last two are gone. So this is at 87th position, right, from left. So it lies in 45th row and 87th position from left.
Sir, can I tell my way how I did it?
Yes, Samrudh.
Sir, to find the position, sir, what we can do is, sir, we can take, sir, so you know that 2025 is 45 square, sir. Sir, then the row before the 45 square row, the row before the 2020 row in which 2023 is, sir, it will end with 44 square.
Right.
Add 1 with 44 square, it will give you the first number of the row in which 2023 is.
Yeah, very good. Yeah.
Sir, and then we find a difference between 44 square and 45 square, and then we subtract 1.
Okay, yeah. Yeah. So Samrudh is doing with the actual numbers, not the pattern. So earlier row ends with 44 square, which you can find. Okay. So 2025 minus that number. So those many elements will be here in this row, and you find out what is first element of this row, that is 44 square plus 1, and then 2024 minus the first element, that will be the position number, right, Samrudh?
Sir, they just have to do 2023 minus 44 squared. Simple.
Yeah, 2023 minus 44 square, or 2024 minus the first
Yes, sir, I did that.
Anybody wants to say something more about this problem?
Sir, can I tell?
Who is that?
Snehal.
Snell, yes, yeah. Snell, little louder. I can't listen properly.
Sir, now the numbers at right hand, at right, they all are perfect squares. So
Yeah.
and they ask us to 2023 and 20 perfect square near 2023 is 2025, and which is square of 45. So and also if we notice that 4 is square of 2, and it is on second row. 1 is square of 1, and it is on first row. 4 is square of 2, it is second row. 9 is square of 3, it is third row. So the number of row is equals to the difference between the number of row and the that square number. So
Yeah.
if we do like that pattern, if we follow that pattern, we got we can find the difference between their the difference, and if we add them both, we got number of row, and there is difference of 2 between 2023 and 2025. So it number of row is 45 plus 44, which is 89, and 89 minus 2, which is 87. So
Right.
it is on 45th row and 87th place.
Yeah. Snell, just one query. In this process, do you want to find 44 square also?
So 44 square?
Do you need to find 44 square also, or
No, sir.
without that? Okay. Okay. So shall we go ahead? Anybody has any doubt with this first problem?
So, can you explain the solution which the person just said, because the volume was very low?
Yeah. So volume was low. So in fact, she said, you look at just squares, and number of elements is a difference between these two. So 9 minus 4, 5 elements. 4 minus 1, 3 elements. So number of elements in that 45th row is 45 plus it's 2025 minus the earlier square.
Oh, okay.
So there are 89 elements in last row, that 45th row, and you'll skip last two. So position is 87.
Oh, okay, okay. So 89 minus 2, okay.
Shall we go for next, second one? This is something related to divisibility. If 792 divides number 29PQ85818R, where PQR are digits, single digits, then find PQR. Okay, so as usual, I'll give you some time to think. You
So
can
that
apply
is,
whatever methods, whatever rules you know.
so that is one or slash. So
One. After 792,
792.
I get a slash vertical line. 792 divides number on this side.
Yes, sir. Okay.
So how many digits are there? 10 digits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's a 10-digit number. So 792 divides a 10-digit number 29PQ85818R, where PQR are single digits. Okay. So we have to find those PQR. As usual, don't disclose the answers. You can write down answer in chat box only to me, or you can raise your hand later on when we discuss.
So I think we did this problem before, sir.
Is it?
Yeah. Or probably say it as homework or something, but I remember you gave this.
Okay, yeah.
No, sir, no. I don't think so.
Anyways, it will be revision, so do it again.
Yes, sir. Long time. Sir, what is W set?
What Vijay?
Sir, you have written something W set is your sir.
I couldn't hear you properly. Will you say it again?
Sir, no, sir, you have written something W H C, Q, R, W.
Acha, that is very well. Yeah.
Oh, okay.
Generally, I have habit of teaching these college students, and there we use a lot of short forms. Yeah, sorry for that.
Okay.
Yes, Saket, if you have done this problem, shall I give one more? Of course, only for each one. Yeah, this is interesting. Simple but interesting. How many primes less than 10,000 less than 10,000, have digits adding up to. Okay, those who have completed second, you can also try third one. Third is interesting but simple. It's not difficult. And write one more. Find remainder when 10 factorial plus 11 factorial plus 12 factorial is divided by 30.
Sir,
Who is that? Aitreya.
sir, does 7 and 2 exactly divide 2 9 backslash?
Who divides 7 and 2?
Sir, no, sir. Does 792 divide this big number?
Yeah. It divides completely without any remainder. So no, just look it carefully, not only to one number. The sum of digits is 2, right?
Sir,
Yes.
sir, are PQ and R distinct digits?
Yeah, PQR are single digits.
Sir, I've sent my answer. Dashraj.
Okay, yeah. Yes, that's right. Yeah, good. Given its answer for which question?
Third one.
Third one. Oh, okay. I'm not calculated. Just one.
I have sent the answer for the third one.
Given, I think it's 3.
Okay, sir. Sir, इसमें आंसर करेक्ट है सर.
Yes, we are. Yeah. Given, I think you have counted 1001, which is not prime.
Okay, sir. This will be well.
Okay, so I'll start the discussion serially 2, 3, 4. So it's better if you focus first on second problem, then on third, then on fourth. Okay.
Is it just 1 minute, sir, please?
Sir, I've sent the primes for the third question.
Dashraj, that last one exceeds 10,000. It's one more than 10,000. So we have to skip that.
Okay. Then only the first.
Yeah.
Distance.
Yeah, Dashraj, you are the first one to answer second problem. So will you say your method?
Yes, sir. So I factorized 792 into co-prime numbers, and they are 11, 8, and 9.
Dashraj, just a minute. I'll go to next page. Yeah, Dashraj is saying answer for the second one. Okay, 792. Dashraj factored as product of co-prime numbers. Yeah,
8
co-prime
into
is
9 into 11.
secret is one, right? So this is 8 into 8, 8 9 the 72, 7 8 9 the 72, right? So further it's 8 into 9 into 11. And luckily we know divisibility test for 8 as well as 9 as well as 11, right? So you can use all three and find some conditions on three variables PQR and get the
So
answer for PQR.
since the number is divisible by 8, the last 3 digits must be divisible by 8.
Just a minute, Dasha. So now product is 8 into 9 into 11. So essentially I should say 8 divides 792 and 792 divides that number, 10-digit number, which I may call shortly as X. Shall I say this means 8 divides X? All of you agree? So such a property is called as transitivity. Transitivity. And in general, it's not always true. Like for example, let me tell you a simple relation. Suppose say A is father of B and B is father of C, then A is not father of C, right? A will be grandfather of C. So in general, everything is not transitive in nature, but luckily divisibility, less than relation, etc. There are some relations which are transitive. So 8 divides 792, 792 divides that big number, 10-digit number. So 8 divides that original number. Fine? Yes, that's right. So
The divisibility property of 8 is that it should divide the last 3 digits of that
So
number.
it divide
What
last
8 are?
last three digits taken as one number, right? So it should divide 1 8 R.
And so R must be 4. If
Yeah,
we
that's the only answer.
yeah,
So R must be 4.
because if we divide, we get 2, and then we have 16, we have a remainder of 2, and 2R should be divisible by 8, and so R must be 4.
So 8 to the 16, 2 is left, and if I take 24, it's perfect division. 8 is the 24. So R must be 4, right? Yeah, good.
And then I took the sum of the digits,
Okay.
and that I got as 46. And since the sum of the digits should be divisible by 9, we get that 46 plus P plus Q is divisible by 9. So P plus Q must be 8.
46 plus P plus Q.
Yes, sir.
So you have put value of R, right? You have put R equal to 4, right?
Yeah.
Okay. Yeah, so the Dashraj has put value of R as 4 and found out the sum of all digits. Only two variables are left now, P and Q. And that sum turns out to be 46 plus P plus Q, right?
So it could be either 54 or 63. And so P plus Q could be 8 or 17.
So 9 divide 46 plus P plus Q, right?
Sir, actually the sum is 45, sir, not 46.
Yeah, the sum is 41, not 46. The sum is
No,
41.
sum will be
No, second. No. R is equal to 4, right? So
R is 4. Yeah.
that R also. So
Yeah,
then it
square
will
is
be
4.
45,
It will
not
be
46, sir.
So it'll be 45, na? It'll be 45 plus P plus Q.
No, no,
41 plus
no, no, surely it's not 45. It's either 46 or
Okay, the sum comes
I mean
45.
something 1 mod 9. That is sure.
It's
So
Wait, so just add the numbers and check. So I'm getting
yeah.
41
So,
plus R, which is 45.
Yes, sir, I'm also getting that.
So can you
Is
go?
it 45?
no. It has to be 46.
Yes, sir. Yes, sir. It
Minus
is 45 only.
And V's
2
V's
plus, 2 plus 9 is 11. 11 plus, wait, 1
8 is
minute.
19.
V's
Then 19 plus 13. So
Yes, sir. So 2 plus 9 is 11. 11 plus 8 is 19. 19 plus 5 is 24. 24 plus 8 is 32. 32 plus 1 is 33. 33 plus 8 is equal to 41. And 41 plus R is, which is 4, is 45.
Sorry, sir. Yeah, 45. Yeah, that's why it's 45. Yeah. But anyway, your answer is correct, that's right. So
P and Q cannot be equal, right?
no, we don't know. They could be anything. So that's not given. So yeah, that's right. Shall I make it 45? I think it's 45.
Okay. So then we have got P plus Q is either 0.
So just a minute. So 9 divides 45 plus P plus Q. Shall I say, to make it simple, implies 9 divides P plus Q?
Yes.
Yeah, that's one condition we get on P and Q.
So
9
then
divides
P
plus
plus
Q.
Q can be 54 or 63. Sorry. 45 plus P plus Q can be 54 or 63.
45 plus P plus Q.
Maybe 54 or 63.
Yeah.
Or it also could be 45 if P plus Q is 0.
Yeah, if both are 0, because they are in between digits, so they could be 0. So that's one possibility. So either both 0 or some will be 9 or some will be at max 18, maximum 18, right?
Yes, sir.
Yes.
Yeah, so what is then condition with divisibility by 11?
So I sum the alternate.
Alternate digits, sir.
Alternate sum should be same. I'll write down the number once again. What is that? Just check if I write something wrong. 2, 9, P, Q,
8,
8,
5,
5, 8,
1,
1, 8, R, and R is 4. So I'll replace R by 4.
Yeah, and the alternate
Then
sum
it will come
have
as
to be
26
19 plus Q and 26 plus.
Alternate sums are these, right? 8, 16, 8, 24, need 2, 26, so 26 plus P, right?
Yeah, and the other one is 19
P
plus.
minus 19 plus Q.
Yes, sir, 19 plus.
Beta. So 9 plus Q plus 5 plus 1 plus 4. So 4 ने 5 ने 5 10 10 9 19 19 plus Q, yeah. 19 plus.
And then you simplify it. You get 7 plus P minus Q more is divisible by 11.
Yeah, just a minute. So shall I say these are congruent mod 11 with congruence notation? Is it correct? The difference should be either 0 or multiple of 11. So shall I say this is congruent to 19 plus Q mod 11?
Yes, sir.
All of you
Yes.
agree? Yeah, so taking all numbers on one side, P minus Q plus 7 is 0 mod 11.
So it could either be 0 or 11.
So P minus Q could be either minus 7 or 4. It cannot exceed 11, right? Because difference has to be smaller than 15. That is for sure. So P minus Q could be either minus 7 or 4. If P is larger, if Q is larger, the difference could be negative, and minus over 7 plus 7 is 0, or it could be 4. 4 plus 7 is 11. So far good.
Yes, sir. And then we just list out the pairs which satisfy.
and then cancel out each of them as you get which is not divides 9.
Yeah.
So now for 9, the condition was 9 divides p plus q, right? Yeah, 9 divides p plus q. That's one condition. And now I put values of p and q, so that difference is either -7 or 4.
So first I took for 4 and then
Okay.
we get 4, 0, 5, 1 and so on.
So I get 4, 0, but p plus q is not divisible by 9. Then I get 5, 1, but again sum is not divisible by 9. Then I get 6, 2. Sum is not divisible by 9. That's
Yeah.
why I think because of that 46.
Yeah. So
Yeah.
bye.
Because
Sorry.
even I got 46, so we both committed same mistake.
Yeah.
I got same 6 twos. Yeah. Anyways, 7, 7, 3. Again, difference is 4, but p plus q is not divisible by 9. 8, 4, but again difference sum is not divisible by 9. Then
9 and pi not divisible by 9.
yeah. So we don't have any answer from this. Okay.
Now go to the next
So we have
question.
to do for -7.
4. Now -7.
So
So
now yeah, -7.
for -7 you'll get 2 and 9, which is not.
Just a minute. So p
So -7.
q. So I get 0, 7. So p minus q is -7, and p plus q is not divisible by 9 again, or
Minus sorry, 1.
Yes. Yes.
1 and 8 it comes to.
yeah.
Yeah, and 2 and 9 is not.
Yeah. So further you can check. I think there will be only one answer because simultaneously to get those two conditions is difficult.
Sir, I have a doubt. If p is 3, then then what will q be if p is 3? Like according to the
Yeah,
11.
in that
Will be
case it
10.
will be -10, but my 10 is not a digit.
Yes, sir.
So
So then
3
so
is
what
a
will happen then?
no, so we won't consider that case. So if p is 3, this case won't arise because q is not a digit. So we want p and q to be digits such that difference p minus q is -7, and we have only these three cases, right? Like for example, here for difference to be 4, I ended at 9. I did not consider 10 and 6 because 10 is not a digit, right?
Yes, sir.
So the answer will be p equal to 1, q equal to 8 and r equal to 4.
Yeah, so p is 1, q is 1, q is 8, and r was 4. Okay, so number has to be, so number should be 2, 9, 1,
2, 9.
8, 8, 5, 8, 1, 8, 4. Oh, there are so many 8s.
Yes, sir.
Let me quickly check if this number is really divisible by 792.
Sir,
Is that? Just a minute. Let me check this. 2, 9, 1, 8, 8, 5, 8, 1, 8, 4. Divided by what is that? 792.
sir, I think yes, sir.
Yeah, that's completely divisible. Yeah.
Yes, sir.
Yeah, so we are correct. Fine.
Yes, sir.
Sir,
Yes.
sir, I found a possible way to find out prime numbers. It has a pattern.
Which one for third one? Next one.
No, sir, no, sir. For prime numbers, I found a pattern.
Okay. So yeah, I mean general primes, not connected with this problem.
No, sir, general primes.
Okay. Yeah, that's good.
Sir, I calculated above 41, not under 41. Sir, can I tell?
Yes.
Sir, suppose we take the even numbers. So from 41, I have calculated how to find out the prime numbers. You add 41 plus 0, it is 41 is the prime number. And you add 41 plus 0 plus 2, and 43 is the prime number. And 41 plus 0 plus 2 plus 4, it is a prime number. Then 41 plus 0 plus 2 plus 4 plus 6, and 0 plus 2 plus 4 plus 6 plus 8, like that.
So all of them turn out to be primes?
Yes, sir.
Oh, good. I'll check a little more about this pattern. Okay. So tell you next time. Sure. Yeah, so everyone is fine with second one, second problem. Shall we go for third one? Yeah, here is third problem.
So is the third one trial and error?
Yes, yeah.
It's just 1 minute. So can you just hold the screen just for 2 minutes?
So explore this condition. Digits add up to 2. Okay, shall we start with third one? So we want to find how many primes are there. So first of all, we want primes which are all less than 10,000 and sum of digits is 2. So how shall we get sum of digits as 2? Either I should have 1, 2 and remaining zeros. Either just 1, 2 and if at all some other digits and possibly zeros. Okay, but with I can't put 0 on right hand side of 2 because that won't be prime number, it will be even number. So none of them will be prime. So only such number is 2, right? So I get single digit number 2. There is no 0. No zeros on the right. Okay, or there will be 2 ones and other zeros. Now how can I put 2 ones and some zeros? So I can do it this way without any 0, that is 11, or I can put 0 in between, 101 or 1001, but that is not prime. Note, this is not prime. Or someone had written this one 10001, but see that it's above 10,000. So it's not valid. So we won't consider this number. So only numbers less than 10,000 containing either 2 or 2 ones and other zeros are 2, 11, 101, 1001. But out of which 1001 is not prime. So factors are well known. It's 7, 11, 30. check. So there are only three numbers: 2, 11, 100, and 1.
Sir, what is the thing that you have written in the bracket?
Possibly zeros and possibly zeros.
So
But
it
with
either
2, I had to keep 0 on left side, right? And you put any number of zeros. Ultimately, that number is 2. I
oh,
can't give it to right side
yes, sir, yes, sir.
because then that's even number and that's not prime. I haven't checked the chat box. Let me check the chat box quickly.
Sir, I sent 2 in the chat box before.
Oh yeah.
Sir, I sent my answer in the chat box.
Yeah, I saw answers now.
Sir, can you go to the slide where the questions are written?
Yes. Yeah, so just a minute. So everyone fine with that prime wala problem?
Yes, sir. So can you just please give like 1 or 2 minutes for
Yes, the last one. Because there you have to work something. Yeah. So answer for this is, there are three numbers, namely 2, 11, 101, all are prime. So there are three numbers.
Oh, that was going to tell them.
What is the answer for
there are
second?
3 numbers. Oh, I made a mistake then.
What is the answer for this PQR? R was 4.
Yeah, then P was 1 and Q was 8.
Okay. Yeah, let me give hint for fourth one. Generally, when we have problems on remainders, best way is use congruence. Of course, we can do it without congruence, but in a complicated fashion. Congruence is always the most convenient way to work with remainders, etc.
Just 1 second.
Yeah. Yeah, by the way, everyone knows what is factorial?
So yes, sir.
Yeah. So for example, 10 factorial is product 1 into 2 into 3 into 4 into so on up to 10. And that's a huge number. So you can't practically work out all those numbers. You have to do some tricks, modulo 30.
Sir, I sent my answer. Is it correct?
Just a minute. In fact, I've found the answer, but like in last problem, I also made some calculation mistake. Yeah,
Sir,
that's not,
is my
yeah,
answer
that's
correct, sir?
yeah, that's a second. Your answer matches with mine. So
Yes.
hopefully we are all correct.
Oh, okay.
In last problem, I got same as Dasraj, but Dasraj also committed a mistake. And I also made a mistake, calculation mistake. In that second problem, PQR.
So can I explain the solution?
First, let me explain some simple tricks, and then you can explain your way. Okay?
So can I also explain?
Yes, sure. Yeah, shall I start? So, firstly, let me say some basics. So, if I divide number a by something, say n, I get some quotient and some remainder, right? So, I say a is n times q plus r, and which means a minus r difference is n times q, or n divides a minus r. And in congruence notation, we write it this way: a is congruent to r mod n. So basically, when I want to find remainder on division by some number n, it's as good as look at that number modulo n. Is everyone clear? Shall I repeat? Our question is, if I divide 10 factorial plus 11 factorial plus 12 factorial by 13, what is remainder? Obviously, remainder should be less than 13, right? So it could be anything out of 0 to 12. That's the idea. But problem in this case is this number is a huge number, and practically you can't work this big number, divide it actually by 13 and find the remainder. So you have to use some tricks like congruence, etc. Everyone agrees? So I have to find this number is congruent to what mod 13. So question is in congruence notation, 10 factorial plus 11 factorial plus 12 factorial is congruent to what mod 13? That's the question.
So can I explain?
Just a minute.
Dashraj.
Wait, sir, can I
Just a
explain?
minute. Just a minute. Wait a minute. So I want to find this number in place of
So what do
question.
you mean by mod and congruent?
Somebody is asking something. Your voice is low. Will you say it a little louder?
Sir, can you tell what congruent and mod mean?
Congruent.
and mod.
We
So
did
you,
2 classes for this.
yeah, so you want this definition. So we say A is congruent to R mod N if N divides the difference A minus R. This is a definition of congruence. So for example, let's take simple cases. So say for example, 15 is congruent to 2 mod 13, right? Because 15 minus 2 is 13 and 13 divides 13. Okay. Or even I can say 6 is congruent to 2 mod 4 or 2 mod 2. Right? Or 6 is congruent to 0 mod 3. Right? So 3 divides difference 6 minus 0. Is the definition clear? In fact, after congruence, I said this is new to you. So you revise from PDF in Google Classroom. I hope all of you revise. Yeah. So let me go to new page. Super good. If you want to copy down quickly, just take a screenshot from this and I'll go to next page.
Okay, sir, can I explain first?
Yeah, I'll give everyone chance. Don't worry. Let me explain first something and then you can say what are your method. Okay. Yeah. So I'm explaining my method and later on Saket and Dasraj will also explain their techniques. So you have to use some tricks which will make your calculations simple, easier. Shall I go to the next page now?
Yes, sir.
Okay, so 10 factorial plus 11 factorial plus 12 factorial. Firstly, what I can do is I can take 10 factorial common. All of you agree?
Yes, sir.
And then from first term, I'll get obviously 1 plus. Now 11 factorial is product 1, 2, 3, 4, so on up to 10, 11. So that is obviously 10 factorial into 11. So when I take 10 factorial common, I'm left with factor 11 from second term. All of you agree? And from 12 factorial, what I get is 12 factorial is product 1, 2, 3, 4 up to 10 into 11 into 12. So what I get is 10 factorial into 11 into 2.
Yes, sir.
Into 11 into 2. Okay. Everyone agrees with this?
Yes, sir.
Yeah. And now I have to look at this number modulo 13. Is this clear to everyone? So you have to find remainder. When
I found modulo 10 factorial, like modulo 13, 10 factorial, 11 factorial, and 12 factorial separately, and then I added it.
okay, yeah, that's also good.
Oh, sir, my method is a little different. So can I say?
Wait. Let me explain something, and then you can both of you can explain your techniques. Yeah. Okay. Yeah. So to find remainder, when divided by 13 is to find this number mod 13. Okay, agree with that? So essentially I have to work modulo 13. And modulo 13 means it's as good as we have 13 clock and numbers are 1, 2, 3, 4 up to 12 and 13 is as good as 0. 13 is as good as 0. 14 is again like 1. 15 is 2. 16 is 3, and so on. Right? Yeah. So firstly, 10 factorial, or maybe let's work this simple number modulo 13. So 1 plus 11 plus 11 into 12 is 12 plus 11 into 12.
Sir, 132.
So that is, yeah. So in fact, idea of congruence is don't work large products. So as far as possible, try to work with smaller numbers. So 12 is like
-1.
-1 when I work modulo 13. 11 is like -2, and again -2 into -1 modulo 13.
That is -1 plus 2, that is 1.
Everyone agrees with this? So this is 2 minus 1. That is 1 mod 30. So this number is 1 mod 30. All of you agree?
Yes, sir.
Yes.
So this bracket is 1 mod 30, and therefore as far as remainder is concerned, it's just 10 factorial into 1. Right? So I have to find basically what is 10 factorial modulo 30.
Wait, sir, can you wait, sir? Can you understand this method?
So again, I'm finding both numbers modulo 13 and take the product. So I have to find 10 factorial is what mod 13, and I have to find what is this number mod 13. So this number is luckily 1 mod 13. So my remainder will be remainder here into remainder here. But this part is luckily 1. So I have to find basically 10 factorial mod 13.
Yeah, so I'm asking about the 1 plus 11 plus 11 times 12, sir.
So that is 12 plus 11 into 12. And I have to
Oh,
work.
okay. Okay. Oh, I understood. Okay, so then,
So I'm using negative numbers. So 12 is -1 mod 13. Everyone agrees?
yes, sir.
Similarly, 11 is -2 mod 13. So idea is work with negative, positive, anything, but idea is work with smaller numbers. That's the point. Yeah. So let's work now 10 factorial. And the trick is following.
So you have to make it in products of 12. Then we can replace it by -1.
Yeah. So 10 factorial is 1 into 2 into 3 into 4 into 5 into 6 into 7 into 8 into 9 into 10.
So you can replace 3 into 4 and 2 into 6 by -1.
Yes, Navita, that's it. And idea is, in fact, you can work in any convenient, suitable fashion. So that you different ways you can simplify. So, for example, what I prefer is find those numbers which will give us 1. So, like for example, 10 into 4, 40, and 40 is
8 and 5.
40 is 1 mod 13, right? So this is 40. 40 is 1 mod 13. Why? Because 40 minus 1 is 39, and 13 divides that. So 40 is 1 mod 13. Then I see 5 into 8 is also 1 mod 13. So this is also 1 again.
Then 6 into 2 is -1.
Yes. So
I don't understand how is 40 congruent.
yeah, because 13 3 is 39 and remainder is 1.
Oh, yeah.
Right? So essentially we have to find remainders.
Okay.
Then 9 3s are 27, and 27 is 26 plus 1. So that is again 1. Okay. Then 7 to the 14, and 14 is again 1. This is again 1. So I have made all pairs which will give me 1, 1, 1. And we are left with just one number which I have to write as it is. So into 6 mod 30. So look carefully whether Dashraj, just check whether I have done correctly.
Yes, sir, it's correct.
So have I taken all numbers?
Yeah, except that one in the beginning, which
That is one. That is one. So 10 and 4, 8 and 5, 9 and 3, 7 and 2. So essentially I have made pairs which will give me 1 mod 30. Okay. So these are called inverses. Like for example, in our regular numbers, like inverse of 2 is 1 by 2. So 2 into 1 by 2 is 1. So we say 1 by 2 is 2 inverse. So on same lines, in modulo 13, I'll say 10 and 4 are inverses. So 4 into 10 is 1, modulo 13. Or 5 into 8 is 1 mod 30. Or 2 into what 7 is 1 mod 30. Or 3 into 9 is 1 mod 30. So check. So I have made pairs of inverses. And I'm left with 6. Okay.
yes, sir. So the 6 will be the answer.
So this number is essentially 6 mod 30. So once again, my number was basically 10 factorial into 1 plus 11 plus 11 into 12. And that is, this is congruent to 6 into this part is congruent to 1 mod 30. So total remainder is 6 into 1. That is 6. So answer is basically 6.
Yes.
See how congruences are so convenient and simple. Otherwise, we have to multiply actually those three numbers, and it's a huge number: 10 factor, 11 factor, 12 factor. They're big numbers.
Can I share my method?
Yes, yes. And you have to actually find numbers, divide that sum by 13, and you have to find remainder, where obviously it's difficult as far as finding those products are concerned, and as well as even if you find correctly, to find the remainder after division to such big number, that's again one big task. So there is a lot of space for error. So everyone has followed that this number 10 factorial plus 11 factorial plus 12 factorial, if we divide by 13, the remainder is 6. We are not bothered about what is quotient. It will be a big number. So now one by one, Saket and Dasra. Saket, follow.
Yes, sir. So, wait 1 minute. So when they say factorial, you don't actually have to multiply because all we want is the mod, right? Okay. So what is 1 mod 13 is 1. You multiply by 2. 2 you get 2. Then 2 mod 13, 1 mod 13 into 2 mod 13 is 2 mod 13. 2 mod 13 into 3 mod 13 is 6 mod 13. 6 mod 13 into 4 is 24. But you can simplify that as minus 2 or 9 minus 2 or 11 mod
Good.
13. So
Good.
if you keep going, it may seem like you're multiplying a lot, but it's very simple. And this method is very good because whatever number you have, you can use this method. Like for example, this method of picking two pairs of numbers and finding whether they are the modulo is 1, that won't work in all cases, but this method will work in all cases. So
Yeah.
all you have to do is just simplify the number. It's similar to, like, doing mod 10 and just taking the last digit. It's just mod 13 this time, so it's the same thing.
Yeah, good. So yeah, I'll say what Saket said. So Saket was doing it this way: 10 factorial is 1 into 2 into 3 into 4 and so on up to 10. And you work this product modulo 30 and reduce at every step. So for example, when I work first, say 3 numbers, that is 6, 6 4s are 24. So 24 is as good as minus 2. 24 is minus 2 mod 13. Everyone agrees? So it's minus 2 into 5 into 6 into 7 into 8 into 9 into 10 mod 13. Then minus 2 into 5, that is minus 10. And minus 10 is again as good as plus 3 modulo 13. Check. In fact, if you solve more and more problems on congruence, you'll be comfortable with all these calculations. So it's just about practice. There is no great concept in that. So minus 2 into 5, I can replace by 3.
Sir, I have a question.
Yes.
Sir, in the first method, in your method, where you went and simplified as 10 factorial multiplied by 1 plus 11 plus 11 into 12, na?
Yes.
So, but in the end, what are you calculating? Because you still have to know what 10 factorial mod 13 is, na?
Yes. Yes. But
So,
your method is more straightforward. In fact, what in my method, what I have to do is find some suitable pairs which will give me 1. And it works because 13 is prime. So as you said, in general, it may not work. So what I did was finding pairs which will give me 1, 1, 1, so that for multiplication it's easier.
oh, okay, sir.
And that works because 13 is prime. So
Then in the end, you multiply by 6 by 6 into
yes.
1. So it's
Yes.
6. Okay, I understand.
So now 3 into 6, that is 18. 18 is 5 mod 13. So this is 5 into 7 into 8. So your method is straightforward. Only thing, it's little lengthy. So you have to work step by step. Mod 13. And then further, this is 7 5 are 35. And 35 is, shall I say, minus 4 mod 13. Again, I can take simultaneously. This is 8 9 are 72. And 72 is 7. Is it 7? 7 mod 13. And again 10 I can say is 10 is minus 3 mod 13. So I have taken simultaneously modulo 13 for all numbers. Now minus 4 into minus 3 is plus 12. So this is 12 sevens are mod 13. Now 12 is like minus 1 into 7, that is minus 7. And minus 7 is again same as plus 6 modulo 30. Check. The difference will turn out to be 6 minus minus 7, that is 13. That is 6 mod 13. Okay, now similarly you work for 11 and 12 factorial. In fact, already we have worked for 10 factorial. For 11, you have to just multiply by one more 11. For 12 factorial, you have to multiply that number by 12 and get all those numbers, add them up, and that's your answer for number modulo 30. Okay, yes, Dashraj, what was your technique?
So I first found for 10 factorial. I expanded it and then I replaced 3 into 4 by -1, 6 into 2 by -1, and like that
No.
only. So it's kind of similar to yours.
Yeah, yeah. Only thing you separately work with 10 factorial, 11 factorial.
Yeah, and then I multiplied by -2 for 11 and -1 for 12.
Okay.
I got 6 plus -12 plus 12, which is 6.
Yeah, yeah. Right.
So we are doing always.
Okay, then, so we'll then stop for today. It's already time now. Fine. And tomorrow we'll continue with more problems, mixed problems, so that we'll have a good revision.